Hello. Should I get started? Yeah, good. All right. Welcome. Damen und Herren, ladies and gentlemen, shadowy supercoders and eldritch entities from the dark forest. Welcome to my talk. I'm here today to talk to you about the future of NFTs and Web3. I think we've heard a lot of talks today about the history, sometimes the deep history back to the very beginning of NFTs. And today we're going to ask, what will NFTs and Web3 become? Web3 now, it's not nothing, but it's nearly nothing compared to what it seeks to become, which is everything. And the thesis that I'm here to discuss with you, fine people today, is that old crypto was optimized for divisible quantities because transactions were, and still are, expensive and clumsy. Crypto's future is a computational universe populated by discrete objects and interactions between those objects. Now, a rich application environment, a peer-to-peer protocol plus mathematically verifiable transaction scaling, that is what transforms NFTs into a cryptoverse. A platform for building peer-to-peer networked apps without transaction scaling is fated to triviality. The ability to do scaling transactions without the platform for building peer-to-peer network apps, that's doomed to endless struggles and hardship. Not a fate that you want your project to fall into. So let me explain. By old crypto, what do I mean? First of all, the ledger currencies we're all familiar with, Bitcoin, Litecoin, Monero, et cetera, as well as Ether, all the L1 native tokens that are used to pay for compute on a distributed virtual machine, and the ERC20-like tokens that are used for governance and for equity shares in those protocols. Up until now, NFTs tended to be treated as an imperfect version of those currencies, imperfect versions of Bitcoin, not as their own thing. That's starting to change now. What does that mean? Let me read to you a line from last year's Messari report. Quoth Messari, NFTs are cool because they represent verifiably scarce, portable, and programmable pieces of digital property. Verifiably scarce, portable, and programmable. Now, if you want advice on what's cool and not cool, you should go with Messari, not me. But my thesis is that scarce and portable, they sound cool for legacy use cases, mainly because they sound like Bitcoin, right? We've all seen Saylor do his bit, the hardest money that ever was. Programmability is where the future is, not the scarcity and the portability. That still matters. But programmability is what is going to make the future of NFTs very, very different from its past. So the legacy use cases, let me run through these quickly. We've been talking about them all morning and for the first part of the afternoon. So you know what they are, but just for illustrative purposes. First of all, NFTs function as registries, right, for sales of physical and digital art. The sales were already happening. They would have happened without NFTs. NFTs are a more convenient way to conduct some of this commerce around art. I'm from Boston, Massachusetts. I attend, bi-weekly meetings of the local NFT group. Almost everyone is an artist. They were originally an artist, and they found that this is a new way to have a registry for what they were already doing. It's also a registry for non-art digital properties. You can use it, for example, we've had people already talking about games, game objects, virtual properties in VR worlds. Also for investments, my own DAO uses NFTs. You just sock the number of shares you want inside the NFT's data structures. You can use them to record achievements or POAPs. And then there's another set of use cases which are more than just registries, still very, very familiar to everyone. Some people treat the NFT as art in itself, not in the sense that they could have bought the same thing over email or something, but it's actually, it's an event. You're part of an event, you're part of a moment in crypto culture, crypto history, and that is an aestheticization of what your ERC-721 token or whatever is doing that is very exciting to some people as an art object. You also have like the profile picture collection concept, which is also big. It's also very important. And there, again, it's not just a registry because it needs to be on chain. You need to have that link there in order for it to be verifiably integrated with all of your all of the sites you use or you want that to display. Now, there's a final legacy use case to mention, which is membership, where, again, when you buy membership, you're not buying something that is like it symbolizes some further thing. The fact that you're listed on that registry that's the membership itself. But this is still something we're familiar with from the physical world. There's lots of utility that can be gained by membership. Saturday night, you know, rave in Brooklyn, I scanned my phone, I got in, not sure exactly what happened for the next 4 hours, but like that, NFTs are great for that. They're great for gating access to other things too, including the other members. For many NFT collections, it's membership is a signal of social capital, right? It can also be like a long-term release of goods. You take the revenue gained during the minting process, and then you release a stream of projects to the hodlers. And it's like Kickstarter for nerds, Kickstarter for bigger nerds. So what unites these legacy use cases? First of all, they're static. They're mostly static, right? The NFT, for these use cases that we're discussing to succeed, the NFT doesn't actually have to change that much in 75% of the cases. They're used for identity, yes, but the number one question is identifying the owning wallet. They make limited use, I would argue, of the qualitative structure of NFTs as opposed to the older fungible cryptocurrencies. And one way to think about this is fractionalization. Fractionalization is very important, it's very useful. It's a big moment for many NFT projects, right? And it allows people to do things with liquidity that are interesting that you can't do without the wrapped version of the token. But it shows that these NFTs, they're not being used as an object, but as a threshold, right? Because what matters is not some qualitative structure of the object, something that you're doing with it. It's whether you reach the threshold at which you receive the membership or you receive the de facto ownership. So what would the alternative be? It's very well to identify that and saying that, in the future, the programmability of these NFTs is going to become much, much more important. But what would the preconditions be to take better advantage of that? First, you need to be able to change and update the data to make use of that. Secondly, the contract calls, they need to be able to see that on chain and read it, do computations on it cheaply. And you need composability. Many, many such calls, all thousands of a penny, in a single use case. And this is a pattern that we've been seeing in computation for 60 years, right? Computations that people don't explore too hard at first because no one can quite see the value in writing up the code rather than just doing that part of the process manually. Once you actually do throw the function into a library and you can delegate the call of it algorithmically, then you can start to compose it with hundreds of others, tiny little functions, and get radically different results than what you had 10 years earlier when you were, computers were glorified calculators. So to get this, obviously, those three preconditions, you need to break through the scalability trilemma first. That's not what this conference is about. If any of you are at Austin, we can argue about this there. There will be plenty of time in the sector to talk about what the best solutions to scalability are. My company, Uqbar, we're writing a zero-knowledge interpreter for a high-level contract language using the Cairo instruction set from Starkware. So it's a low-level but Turing-complete, recursive, et cetera, language that will produce an arbitrary Stark for whatever you put into it. And there are lots of other, so that's what we're going with, but lots of other ZK strategies exist. More and more people are interested in Plonks. Zcash just announced they'll be moving to Plonks soon. You know, I don't need to enumerate these for you. In addition to zero-knowledge strategies for scaling, there are optimistic strategies. There are various creative things that the alt L1s are trying, which, you know, they've had a rough couple months, but they'll have their day in the sun again before all is said and done. And I don't want to argue about that, just black box what it is that you want to be trusting in, whether it's math or game theory. But assume that we have the transaction scaling that we need to make this happen. What else do you need? And I think the answer is you need a seamless execution environment. Seamless execution environment. This has one meaning from the point of view of user experience and another meaning from the point of view of developer experience. And these complement each other, right? So users, they obviously need trusted and autonomous platforms. Users need integrated apps to avoid front-end hacks, front-end spoofing, browser and browser stuff. This has been happening more and more, and in the end, it is as much of a problem to like the value of the crypto thesis as underlying exploits in the smart contracts themselves. Users need app-to-app integration so that apps can interoperate on-chain and off-chain. And users need app-chain integration, obviously, but they need tight app-chain integration, right? So that the app can, you know, a local computation can be sent directly on to the chain and executed as a contract call, and the outcome of the computation performed on-chain can then be sent directly back and executed locally. And the question of how you offer this to end users, that's what makes seamless app functionality from the user's perspective a question of seamless app development from our perspective, from all of our perspective. The most seamless execution environment for applications, in the end, there's a sense in which it's the one that's the most fun as a playground for the devs who are building in it, right? So scaling, when I say scaling isn't enough, you also need this seamless execution environment. What I mean is next generation NFTs, they require a next generation platform for peer-to-peer development. And this next generation platform for app development, that's going to require these kinds of new qualitatively complex NFTs to function as its basic infrastructure. So when we talk about a seamless execution environment like this, without the constraint that the computations we're interested in, they need to be massively peer-to-peer, they need to be cryptographic, they need to be highly decentralized. The kind of integrated seamless execution environment we're talking about, what is it? I mean, can we guess? It's the title of the talk. It's called an operating system. Operating systems are solved problems within the constraints that we've released. If you don't care about having them function peer-to-peer, decentralized, trustlessly, since the 1970s they've been solved, right? You know, for 30 or 40 years after World War II, they were putting together more and more of this tooling, and finally they integrated it, and now we're all using the daughter systems. But that was primarily for a different kind of use case, the sorts of things that the guys at Manhattan Project, ENIAC, Bell Labs, they were not concerned primarily with networking. It wasn't the primary intended use case of the modern computing stack, and there are a number of problems. A developer of a piece of the Web3 infrastructure stack, he'd like to be able to solve, or that he must solve, that he's gonna run into again and again and again and again. And many of these have been talked about already today. You're gonna want a public key infrastructure, right, for persistent identity and reputation. You need some sort of solution to routing and tracking. You have issues with serialization and deserialization. Many people don't even think of this as like a DevX problem that can be solved at the level of an execution environment, but some people will complain that they spend the majority of their time trying to figure out how to get the data from one node to another when it could be coming from a very, very diverse array of different stateful starting points. You would probably want to solve event tracking. You would want some kind of consistency between nodes, both cryptographic consistency, but also really just, sequencing, like what happened first, what happened second. Several crypto projects have solved one aspect of this problem space. Some have solved two, which is great. There are also a ton of little crypto projects. I think you'll note the kind I'm talking about, like collaborations between one group that solved one of these problems, another group, they have a different solution to a different problem, and they're gonna work together to make those two applications, like jam them together. Like you jam them together, you wrap around the duct tape, you tie a ribbon on it, and that works. And it does work, and it is exciting because this is the direction that the space needs to go, and people are very, very perceptive to see that each step in this direction is moving towards something, a cryptographic universe that is going to be amazing. However, it's not sustainable to do it that way, right? Like once you've wrapped the duct tape around two of these tools, like once you add the third one and you duct tape each of the first two together, you have a combinatorial explosion of duct tape here. So no matter how excited the tweets are about, they're working together, googly eyes, if you know, you know, the long-term trajectory of these projects is doomed to frustration unless you approach them in a principled and consistent way. And so meanwhile, operating along a different track entirely for a much longer time frame, we have Urbit. Urbit is an actual literal operating system that solves all these problems just once in an integrated way at the kernel level. Urbit, it's natively networked. Urbit gives you your own little database, a transaction ledger for peer-to-peer computational events and objects. Urbit makes identity a first-class primitive. It makes network topology a first-class primitive. It bakes consistency into every interaction with other nodes on the system. It bakes the cryptographic identity, your cryptographic identity, into the kernel of your computer when you boot up your instance of the Urbit virtual machine. So, and it also has some fun stuff that developers like, that it's purely functional, it's typed. These are intrinsically important things, even if you're not a big fan of functional languages in general. They become important when the security model of your software is the top priority, because when you are producing tons and tons of side effects, you get so many complicated and unexpected interactions. You get a complexity cascade similar to the complexity cascade we discussed when you're duct taping together different tools that were never intended. They were intended to work well, but not intended to work well together. So that's why my company, I don't work for Urbit. Those gentlemen are sitting up front. I work for Uqbar. That's why my company, we're building our ZK scaling smart contract platform on top of Urbit. It runs on the Urbit virtual machine. It'll be a layer 2 on Ethereum. People said, it's interesting. They said we should do a cookie cutter Cosmos chain, right? And those chains work great, which is why the recommendation makes sense. They said, you can do that and you can deploy the testnet in 5 months. So we're getting ready to deploy the testnet after 7 months with a brand new architecture, which is fairly fast, and we're all still friends and having fun, which isn't something, it's not something that every project that does that in 7 months can say. So for us, the next step is, we are going to deploy our testnet. Other people can start writing apps that integrate into our smart contracts. We expect rapid project in that ecosystem, first cloning apps that absolutely every chain in the world has, then new NFT-enabled applications that only ZK scaling on a seamless Web3 execution environment can provide. It's going to be very, very exciting. Urbit is not, by the way, the only thing that could make this possible, but it's the only thing that currently exists that could make it possible. It's been in development for a very, very long time. It still has rough edges, of course. I believe the company was founded in 2010, the company that leads development, Tlon. But the underlying kernel architecture was being developed for 7 years before that. So it's a 20-year project, and if, we like met at the after party and we decided we were going to build a new one, but even better, I think it would take another 20 years. Facebook could probably do it in 5 years or less if they wanted to throw a ton of resources at it. But that's what you need. You need a real crypto OS, like a literal operating system, because that is what a sustainable, fully integrated solution to all of these DevX tooling problems is. And without that solution, we're never really going to get to the point with where the apps execute in a way that the users like either. So, I don't know. I can go through use cases for what you could actually do. Some people have some very exciting ideas about what you can do with, full-fledged NFTs, huge complexity of the composition of different calls that you make. There's one guy who wants to do have you guys heard of him? Guilty Gyoza from Topology. He wants to do an on-chain patent registry that, you call the patent and it runs a physics simulation to see whether the patent works or not. So that's wild, right? But you can't do it right now. Right now, NFTs are not really robust enough. They don't make use of the qualitative structure of that NFTs make possible sufficiently to support that kind of massively composed physics simulation. However, it is going to be possible. It's going to be possible sooner than you think, probably. There are other use cases, autonomous, delegated, hot wallet stuff, decentralized reputation. That would be the next step to under-collateralized loans, which are one of the holy grails of DeFi. A lot of these things have been talked about by other people who are attacking them from other directions, but I would say the first thing you want to solve, once you have your scaling, you also need some kind of platform for developing peer-to-peer applications sustainably. So yeah, we're looking forward to a very exciting future. All of us in this space. There's going to be a techno-commercial, quasi-universe out there filled with all of these objects interacting in ways that we really can't even predict because it's so new and you're going to be able to do so many things with it. All we know is that these projects that want to do exact simulations of real physics, like persistent virtual worlds, that's just the starting point. We can't imagine what the endpoint will be. We only know how we get there, what the first step is. And so that is why I began the talk, with apologies to the abbesiers, by saying, what is Web3? Nothing. What does it seek to become? Everything. Thank you.